Hello everyone. Welcome to our comparison between Python and R for data analytics. Today we're going to talk about random forest classification. So the underlying rationale here is that random forest classification is a type of ensemble learning where you can see that we make a random forest of multiple trees. For example, in this case, let's do 3 trees. Then each tree will take a subset of the total data set, learn the model, and make prediction. And after that, when all trees come together, we'll have the majority voting. Whichever prediction that has the most votes will be the final prediction of the random forest. So this is multiple trees coming together to vote for a decision. The real world application of this is fraud detection, user behavior, and medical diagnosis. The data set that we look today, we're going to show you an example that the goal here is we have a data set of recordings from 3,000 people, male or female, with the data set of mean frequency, median frequency, the peak tone, and the lowest tone, and other data points. From that, the model will classify that either as male or female. And this will be relevant to Google because Google will need to identify which user is making the command in Google Assistant, for example. Now let's go back to the code. Here, you can see that, let's look at our Python first. We will first need to import the libraries, and then we'll import the data set, identify the independent variable and dependent variable. From that, we'll start to encode the dependent variable y. So why do we have to encode this? Because right now, the data set is male or female, and the machine can't read that. So we have to encode that as 1 and 0 for the machine to train and make prediction. From that, we will split the data set into the training set and the test set and do it as the 25% is the test size. So 75% of the data will be used to train the model, and 25% will be the test set. After that, we will feature scale to normalize the data so that the machine model can run faster. After that, we will fit the random forest classification into the training set, and the number of trees that we have here is 10. After that, we will make the prediction, and finally, we'll make the confusion matrix as you can see here. So we have 367 correct predictions as female and 406 correct predictions as male. So the total accuracy rate is roughly around 97%. Now let's take a look at what R can do. We also have the similar steps. First, we'll import the libraries, and then we'll import the dataset. We'll also the same step to encode the dependent variable y, and then we will split the dataset into the training set and the test set, and the same ratio of 75% to 25%. After that, we will normalize the data to make the machine learn faster, and then similar steps fit the random forest classification into the training set with the same number of tree, which is 10. And then we will predict the test result and make the confusion matrix. As you can see here, we have 384 correct predictions as male and 387 correct predictions as female. With R, the accuracy is actually higher at 98%. Now you have seen the code from both Python and R. Now let's take a look at